Hello, friends. In March 2003, the FBI arrested 44-year-old Andrew Carlson. Newspapers reported that this man was extraordinarily lucky. In the history of stock markets, he had earned like no other. He invested $800 and within 2 weeks, it turned into $350 million. The FBI suspected that he was running a scam, that he was an insider trader. When Andrew was questioned, he answered that he was a time traveler. He claimed that he was a traveler from 250 years in the future, and that he knew how the stocks would perform, so he invested in them. Before proceeding, please subscribe to our YouTube channel. Thank you. And got the extraordinary result. The FBI was surprised at this. The FBI was convinced that he was lying, and they took it upon themselves to prove that he was lying. When they investigated some more, they found that before December 2002, there was no record of Carlson. Even more surprising was that on the 3rd of April, Carlson had to appear in court for his bail hearing. But he had disappeared, never to be found again. Was he really a time traveler? Is it really possible to travel through time? Or is it only fiction for novels and films? In today's video, let's understand the concept of time traveling scientifically. Great. Are you talking about a time machine? You know the rules of time jumps, right? Time travel, a concept that has been explored since the early 1900s. I have no idea, but when we're talking about time travel here, either it's all a joke or none of it is. In 1895, writer H.G. Wells wrote his groundbreaking novel, The Time Machine. It was after this that the phrase, time machine, became popular. A machine that can take you into the future as well as the past. With it, you can travel through time. Although this novel was fiction, a science fiction novel, but several philosophers and physicists were inspired by it. Not only were serious research papers written on time travel, but many films were also made. If we think about it, the exact way time travel takes place can be used to classify it into different types. First, let's use sci-fi films. To understand this concept better, time travel can be of many different kinds. The first is the one-way travel to the future. You travel to the future and you can't return. It is one-sided time travel. Interstellar is an example of this. In it, a time traveler traveled to the future, but his family members and other people keep on aging. When he meets them again, some had even died. The second way is instantaneous time jumping. A person can jump from one point in time to another instantly, using a time machine. It was shown in the film Back to the Future, and in The Girl Who Leapt Through Time. The third way can be when the time traveler stands still, and it is time that is moving around the traveler. This was shown in the film Harry Potter, Prisoners of Azkaban, when Hermione uses the time turner. The fourth is slow time travel. As shown in the 2004 film Primer, the time traveler gets inside a box. With every minute he spends in the box, he goes back into the time by a minute. So if he wanted to go back a day, he had to remain in the box for a day. The fifth is traveling at the speed of light. To travel through time. This was shown in Superman, 1979. In it, Superman flew faster than the speed of light, and travels back in time. The question is, among all these concepts of time travel, which way is actually possible today? In real life? Which way may be possible in the future? And which way is completely unscientific, and will never be possible? Don't be surprised. You might think that all of these are rubbish, science fiction, and can't be possible. That's not true. Some of these are actually possible to do, even today. Broadly speaking, there can be two types of time travel. One is to travel into the future, and the other is to go back into the past. Let's talk about traveling to the future first. The scientific explanations and theories of traveling to the future are derived from Albert Einstein's theory of special relativity. The concept of time dilation was introduced by Einstein. Before Einstein, it was believed that time is constant. Whether you're on Earth, or on Mars, or near a black hole, time was believed to be something that was constant. One of the most famous mathematicians and physicists in the world, Isaac Newton, was the one to say this. In his opinion, regardless of the speed with which you're traveling through space, regardless of the position, the flow of time would be constant. Albert Einstein was the first person to refute this. He said that Newton was wrong. Time isn't constant. He claimed that time was like a river. Like water flows in a river. Sometimes it slows down. Sometimes the flow of the river speeds up. Similarly, the flow of time. Sometimes it slows down and sometimes it picks up the pace, depending upon speed and gravity. Yup, you heard it right, Einstein had said that. Time can actually be sped up and slowed down, if the speed and gravitational force could be changed. This is known as time dilation, the way that your pupils dilate. Similarly, time dilates too when the speed of the object increases, or if an object is subjected to an increased gravitational force. How had Einstein actually discovered this? We can talk about this in some other video. It's a long explanation. It took me days to understand that, so I won't go into that explanation. Basically, time dilation can be done in two ways. The first is with speed. If you are sitting in an object that is going very fast, like an aeroplane or a spacecraft, the faster something goes, the more would time slow down for it, relative to a person who isn't going as fast. If I have to explain it with a practical example, suppose you have two clocks. I keep one clock with me and put it on the ground, and I send the other clock with you on an aeroplane. The aeroplane goes around the Earth once and lands back. If we then compare the two clocks, though the clocks showed the same time initially, but now the clock that you took with you on the aeroplane, the time it shows would be some nanoseconds behind the other. The two clocks wouldn't show the same time, because one clock was traveling at a higher speed. It's subjected to kinematic time dilation. I'm not making this up. There was an experiment in 1971. Atomic clocks were used, because time was to be measured precisely, and it was seen that the clock that was in the aeroplane, the time it showed was behind that of the other clock. This was known as the Haffler-Keating experiment. This had proved Einstein's theory of time dilation. It doesn't mean that time is actually slowing down for the clock, the one on the aeroplane. Rather, it means that time is relative. If we observe the clock on the aeroplane from the ground, time slows down in our relation. Because we're seeing it, time is slowing down. For a person on the aeroplane, and the clock on the aeroplane, for it, time would continue to move as it did. Theoretically speaking, if we could build a rocket that travels at the speed of light, and you get in that rocket, you remain in that rocket for 10 years traveling at that speed, and then you return to Earth. The time that you see on Earth would be 9,000 years later. Simply speaking, if you want to travel into the future, you can already do it now. It is scientifically possible to do so today. The only problem is that there isn't an aircraft that travels at this speed. You can get to the speed of light, but with improvements in technology, we can build more such aircraft and spaceships that can fly faster. It would slowly become possible. For now, Gennady Padalka, a Russian astronaut, is credited with the most time travel into the future. It's because he remained in space the longest, 879 days. And he was traveling at the speed of 28,000 kilometers per hour in space. Accordingly, he has traveled 0.02 seconds into the future. In comparison to the people on Earth, he is 0.02 seconds younger, with which we can travel so fast that we can travel through time significantly in the future. Don't be upset, because there's another way of time dilation as laid down by Einstein, by using gravitational force. Similar to time dilation with speed, gravitational force leads to time dilation too. More the gravity, more would be the time dilation. The time dilation that takes place because of gravity. To visualize it, Einstein asked us to imagine a fabric of space-time. Imagine a mesh, like shown in this photo, and put balls on it. You can think of these balls as planetary objects. The heavier a ball would be, the more this mesh would get wrapped. The more mass in the ball, in the planetary object, the more would be its gravitational force. Earth's gravitational force is less than Jupiter's. Sun's gravitational force is more than Jupiter's. Similarly, in the fabric of spacetime, you get to see a curve with the gravitational force of an object. The closer you get to an object with a high gravitational force, the more would you feel time slow down. Time would slow down for you. In this mess, you can see, the steeper the drop is, the more time slows down for you. You can have an approximate estimate with this visualization. This basically means that if you want to travel through time in the future, spend some time near Jupiter, or around the Sun, or near an object that has even more gravitational force, like a black hole. If you spend some time near a black hole, time would pass you by slowly. This is the same concept shown in the film Interstellar, if you remember. The main character in it lands on a planet near a black hole, and each hour he spends there, it's 7 years for the people not on the planet. That was the amount of time dilation in that film because of the black hole. It is a scientifically accurate depiction. It will actually happen like so. But whether someone can survive being that close to a black hole is unknown. It's said that black holes are the heaviest objects in the universe. It's also said that light starts bending around black holes. This was considered to be purely theoretical. But 3 years ago, a telescope clicked the first picture of a black hole and proved it. On the 10th of April 2019, the Event Horizon telescope clicked this picture. This photo went viral on the internet, because this is the first rendered visual image of a black hole. Anyway, if we get back to time travel, I told you 2 ways of traveling into the future. The first is to travel at a high speed, and the second is to get very close to a gravitational object with a high gravity and a high mass. Practically speaking, I would like to give you another example of this. The GPS satellites that keep revolving around the Earth at a high speed. They are farther than Earth's gravity than compared to us. That's why we get to see time dilation, in both senses, in the GPS satellites. And the scientists need to keep rectifying the time calculations on those satellites because of this time dilation. If they don't rectify the clocks on the satellites, then the time on those clocks and those on Earth will differ. There would be problems with GPS communication. Interestingly, friends, there is a third way of time traveling in the future. Cryosleep. It has been shown in many films too. There was a recent film Passenger, you might remember. People were traveling on a spacecraft. They were frozen. They were in cryosleep. In it, for months and years, humans are put into a condition where they don't age. They remain asleep. It's science fiction. But in reality, NASA is trying to develop a stasis chamber. In it, astronauts would be kept in a state of mild hypothermia, in a cold environment. In it, astronauts would be able to sleep continuously for 2 weeks. A hibernation of sorts. The concept behind it is that when a body is kept cool, the chemical reactions in the body would slow down to quite an extent. This would lead to energy conservation in the body and would slow down aging. There was a case in Japan related to this. An injured man survived 24 hours without food or water, when his body went into a hibernation of sorts. The temperature of that man's body was only 22 degrees Celsius. Normally, if a human body is this cold for a long time, it may lead to death. But by chance, I don't know with what miracle, not only did this man survive, but he also made a full recovery from that mode after his body was discovered by someone else. Medical reports claimed that there was no permanent damage to his body. His organs had slowed down, and his brain was unharmed too. Cryosleep is something which may be developed in the future by NASA or some other space agency. We'll have to wait and watch. But you would have noticed one thing. All the ways I talked about till now were of time travel into the future. What about the past? Can we travel into the past, realistically? I sort of told you one of the ways to do it in the video on the James Webb Telescope. As of now, we can't travel into the past, but we can get a glimpse of the past, because it takes a significant time for light to travel from one place to another, even with how fast light travels. If we talk about distance in light years, it takes years for light to travel to some places. So if we could get somewhere before the light reaches there, and then look back at the approaching light, the light would be from the past. That is how we can see the past. I explained it in detail in that video. You can watch it to understand. This was getting a glimpse of the past. Can we actually travel through time into the past? On the 28th of June 2009, world-famous physicist Stephen Hawking hosted a party at the University of Cambridge. There were balloons and champagne at the party. But what was special about the party was that Though everyone was invited, no one attended. Stephen Hawking had hosted this party for time travelers. If a time traveler was visiting our timeline from the future, they were welcome at this party. This comedic experiment was conducted to prove that it isn't possible to travel to the past. Had this been possible, we would see future time travelers all around us. Where are the travelers traveling to the past? Why don't we meet them? Theoretically speaking, Einstein's theory of relativity doesn't disprove time travel to the past. Einstein had said that in the mesh of spacetime, if a gravitational force is put on it that is so heavy that the object falls through the mesh, it would create a wormhole. We can use that wormhole to travel into the past. It's said that to do this, we'd need an extremely powerful gravitational field, similar to the one of a black hole. Perhaps a spinning black hole can generate so much gravitational field that it bends the curvature of the spacetime back on itself. It would create a close time-like curve, known as CTC. You can try to understand it through this diagram. You can try to imagine it. Nobel Prize-winning physicist, Kip Thorne believes that small wormholes get created and then disappear in space all the time. But they are really small. Smaller than atoms. And if we want to travel through them, we would need to open them up somehow. It would take a lot of energy to expand them. Not only normal energy, but we would need negative energy also. Negative energy is a kind of anti-gravitational energy that would repel the fabric of spacetime. Like the same poles of magnets repel one another, negative energy would work in the same way to repel it. This would make it possible to keep the wormhole for a long while and to travel through it. How would this negative energy be harvested? How would it be created? It's something to think about. This is purely theoretical for now. But it is a theory by a Nobel Prize-winning scientist, so it holds a lot of weight. With this, you may think that it might be theoretically possible to travel to the past. But when we talk about traveling to the past, there are a lot of hurdles. There are major obstacles for us. I'm talking about paradoxes, such as the grandfather paradox. The paradox goes like this. Suppose I go to the past while time traveling, and I kill my great-grandfather. If he dies, how would I be born? If my great-grandfather died, I shouldn't be alive. And if I was never born, I never existed. How could I have gone to the past and killed him? How do you explain this? This is a paradox. Either I'm alive or I'm not. This goes against logic. There are some theories to explain this, such as the theory of multiverse. The theory claims that what happened once was in one universe. But when you travel back in time and change something, it would create a new universe, creating a multiverse. So there are multiple universes, with different things happening. Related to this, there's another paradox. The predestination paradox. It claims that when I go into the past and do whatever, everything I do shapes my present timeline. This paradox claims that things are destined to turn out in a certain way. Things will play out as written in destiny, no matter how much you try to change the past. Whatever you try to change, and the result of that change, would be your present. If you're confused, let me give an example. Suppose your friend meets with an accident, and he dies. I hope it doesn't. But imagine that it happens. And you have a time machine. You go into the past, and try to prevent that accident from happening. But what actually happens? By going into the past, you have done something that actually caused the accident. And then you find out that it was because you went into the past, and you tried to prevent that accident. That was the reason for the accident. This was the concept in many films. 12 Monkeys. Time Crimes, 2007. The Time Traveler's Wife, 2009. Predestination, 2014. Overall, there would be many logical problems when traveling to the past. There would be paradoxes. Due to these, it may never be possible. But traveling to the future, it is possible, even today. And it will become more and more probable in the future. And to get a glimpse of the past is currently possible too. So in a sense, time travel already exists. And as shown in films like Interstellar, it was the scientific truth to an extent. But what about Andrew Carlson's story? I didn't say much about it. The story that I told you at the beginning of the video, friends, was actually a story published in a satirical newspaper called the Weekly World News. Later it was printed by Yahoo News, and several other media organizations reported the story as if it were fact. But the truth remains. That story was a satire. It was fake news that was circulated in newspapers, and people believed that it was true. It was a fabricated story basically. I hope you found this episode informative. I have made 2 other episodes in this series. One on the Malaysian Airlines flight, and the other on the mystery of the Bermuda Triangle. You can watch both episodes from this playlist. On which other topics would you like to watch more videos in the future? Let me know in the comments below. Some unexplained, mystery-related topics that don't have enough scientific explanation. Drop your suggestions in the comments. Thank you very much.